Okay, we're looking at exercises 4.2, which is on page 118 of Active Maths 3, and we're talking about questions 6 to 11. So the square root of 25 is 5, the square root of 49 is 7, the cubed root of 27 I recognise as being 3, and the fourth root of 16 is 2. They do say don't use a calculator, but if you have to use a calculator, just use a calculator. The fifth root of 32 is 2. The 10th root of 1 is 1. The square root of 36 is 6. The fourth root of 81 is 3. The sixth root, you see 2 to the 6 is 64. Now this is where it comes in really handy knowing things like this. So the sixth root of 64 is 2, and the square root of 121 is 11. Moving to question 7. Okay, question 7 uses rule 7. Funny enough, so it's rule 7 and it's question 7. So it takes 16 to the power of a quarter is 2. Take 27 to the power of 2/3. First take it to a third is 3. 3 squared is 9. 64 to a third is 4. 4 squared is 16. 16 to a quarter is 2. 2 cubed is 8. 100 square root is 10. 10 cubed is 1000. 125 third cubed root is 5. Square of 5 is 25. 2 to the 5 is 32. 3 cubed is 27. 3 cubed is 27. 4 to the 4, 256. Where we learned that today. Check it really quick. Okay. And we're down to page question 8. So in question 8 we're distributing powering over multiplication. It's rule 8. It's rule 8. It's the second from the bottom in your tables. Okay. So we're going to go write it down as it is first. Now distribute the powering. So you're going to get 3 cubed. You're going to get x squared cubed. We'll deal with that in a second. And we're going to get y cubed. That's 3 cubed x to the 2, 3, 6 y cubed. Okay, now that's kind of simplified. If you want to say that's final answer 27 x to the 6 y to the 3. Okay, now the next one we can apply rule 7 first of all. Not rule 7, rule 5, and it'll become 1 over 2 t to the minus 3 all to be squared. But now let me do this the way I would normally do it. Okay, I would inside is we'll apply the rule t to the minus 3 inside, which means t to the 3. We'll apply the rule of look, t to the minus 3 on top is worth t to the plus 3 on the bottom. So that's the top done, and it's still to the power of minus 2 because we've done nothing outside. Now, one of the consequences of the negative power is that basically that 2 upstairs becomes 2. It looks like that. And the t to the 3 downstairs. Look, to make a long story short, let me just introduce a rule for you. That if you have a fraction to a negative power, you can flip the fraction upside down. and keep it to a positive power. Okay? It's distributing. You could also distribute the power. 2 3s is 6, and then you would go, but the t has to come up, t to the 6, and the 2 has to go down. But you can also flick the fraction and make the negative positive. And it's a bit of a fine detail here now, so I want to kind of repeat it again. We'll just do a quick reset, pretend I said nothing. If you're confused now, don't worry about it. So we go like this. Operationally, this is what you want to do. Eliminate the negative power inside the bracket first. Now, I'll convince you, because of the nitty-gritty of it, that you can flick the fraction upside down and just turn that into a 2. Turn it from -2 to +2. And now you can go ahead and distribute the 2 across the quotient. Now distributing the 2 means 6. Final answer 2 to the 6 over 4. Okay, that's a lot of fun. On to question 9. So using a combination of 2 laws, but don't worry, we'll get that as we move along. Okay, so first question, 100 to the -1/2 is 1 over 100 to the +1/2. Now for some of you thinking in old money that's 1 over square root of 10, which is 1 over 10. And some people, it takes a long time to get used to the power of a half and think of it as being comfortable in considering it intuitive. So if you do want to go back to what I call old money notation, and it does have limitations for computation, you can still go back to the old notation whenever you want. Okay. 36 to the -1/2 equals 1 over the square root of 36. 1 over 36 to the half, 1 over the square root of 36 equals 1 over 6. 16 to the -1/4 equals 1 over 16 to the 1/4. Now for most people this kind of old money thing isn't really of much value because you're not used to seeing that. You never saw that in primary school. 16 to the 1/4 is 2. Okay. 1 over 9. Sorry, going off screen there. Oh, I hope that wasn't bad for all of them. I'm telling you I'm trying to work on the quality of these videos. And at the same time keeping them rough and ready and not over finished. Because you just want to see the maths. I think we're doing pretty well here now. Let me bring that into picture. Right, so I've taken 9 to the -3 over 2 and I've eliminated the negative power. Now I'm going to deal with the 9 to the half, which is 3. And now I'm going to just finish it out as 1 over 27. Okay? And for your confidence, rather than looking at the back of the book, you might like to just key it in to the calculator as 9 to the power of -1.5. Moving across the way now. We have 81 to the -3/4 equals 1 over 81 to the 3/4. I've eliminated the minus power. Now I'm going to eliminate the quarter because by going, that's 1 over 81 to the 1/4 is 3. And that's 1 over 27. 8 to the -2/3 equals 1 over 8 to the 2/3 equals 1 over 2 squared equals 1 over 4. So as you see, knowing the rules and being able to apply them fluently are two different things, and this is why we're doing this. And if you just follow along with me and just practice and practice, practice, you get the idea of what's kind of expected. So the mental process is eliminate the negative power by going downstairs, eliminate the fractional power by taking the square root of 9, and then try to get 3 to the 5, which from memory is 24/3. Okay? So 1 over 24/3. They can start becoming possibly a bit tedious, but then again, practice makes perfect. So 1 over 25 for this one. Eliminate the minus with 1 over fraction 16 to the 5 quarters. 16 to the quarter is 2. 1 over 2 to the 5, but that's equal to 1 over 32. Okay, 1 over 10 to the 5. 1 over 100,000. So evaluate using a calculator. Well, we don't need a calculator. 1 over 2. 9 over 5. 8 over 27. 1 over 5. Because you're taking the square root of 25. Take the cubed root of both. Take the cubed root of both and then you're squaring. 9 over 16. Square root of both. Cubed root of both. Okay. Again, I don't know why. They're just making sure you're able to use your calculator. And that's great, but I'm going to do it without a calculator. So, and it's particularly good time to use this fraction to a negative power. Flip the fraction and turn the power positive. Apply the power above and below. Okay, working down the page. Flip the power and take square roots above and below. Flip the fraction and change the sign of the power to positive. Distribute the power. Flip the fraction. Change the sign of the power to positive. Distribute the third. Distribute the squaring. Flip the fraction. Change the sign of the power. Distribute the denominator. Square the top and the bottom. Flip the power. Flip the fraction. Change the sign of the power. Don't flip the power, okay? Distribute the third. Distribute the squaring. Two to go. Let's squeeze them in here. Flip the power. Flip the fraction. Change the sign of the power. Take square roots. do cubing. Last one, reciprocate, negate, fancy word for changing sign, distribute the root, distribute the square. Now it's taken me a while to do my homework, and I'm gonna leave it at that for that, because that'll fit on a OneNote. I'll start another video for the next one.